right, class section 6.3 is about exponential functions. So we're going to be graphing exponential functions, determining whether something is an exponential function, and learning to solve equations involving exponents. So a good example of an example. Okay. An example of an exponential function is this. So I have f of x equals 2 to the x, okay? So here I'm substituting x in as a power for 2. So if I have x equals negative 1, that'd be 2 to the negative 1, which is a half, right? If I have x equals 0, I get 2 to the 0, which is 1. If I have x is 1, I get 2 to the first power, which is 2. And if I have x is 2, I get 2 squared, which is 4, right? So this is an example of an exponential function. If a is greater than 0 and a doesn't equal 1, because remember if I had 1 to any power, that's always 1, so that's not very exciting. Then the exponential function is a function of the form f of x equals a to the x, where a is greater than 0, a doesn't equal 0, and the base a is called the growth factor. So my a has to be greater than 0, and it can't be 1, and it can't be 0. So why don't we go ahead and solve f of x equals 2x for each of the following. So if I have f of negative 1, that's 2 to the negative 1. Remember that negative exponents are fractions, right? So this becomes 1 over 2. If I have f of 3, that becomes 2 cubed, which is 8. If I have f of 5 halves, that's going to be 2 to the 5 halves, which I can rewrite as 2 to the 5th to the 1/2, right? I can pull that fraction apart. So that gives me 32 to the 1/2. Remember, if I have something to the 1/2 power, that's a square root. And the square root of 32 is 4 square root of 2, because we have to simplify all of our radicals. Note, if it asks you to find it for a decimal or a radical, go ahead and use your calculator for that one. I'm not going to ask you to do that on the exam, but for some reason I think it might on the homework. So just go ahead and take 2 to the, use your parentheses, 4.92, and that would give you right about, because I rounded, 30.2738. So there's a theorem, right? There's a theorem in order for us to determine whether something is an exponential function. So if I have an exponential function where a is greater than 0 and a doesn't equal 1, and x is any real number, then if I take f of x plus 1 over f of x, that's going to equal a. So let's think back to f of x equals 2 to the x, right? When x was negative 1, I found my ratio to, I got a half. When x was 0, I got 1. And when x was 1, I got 2. So if I take f of 0 over f of negative 1, so here's my x plus 1, here's my x, that would give me 1 over a half, which is 2, which is my a, right? We knew that. If I take f of 1 over f of 0, that gives me 2 over 1, which is 2, all right, which is my base. So if I take this ratio, I can determine whether or not something is an exponential function. So let's work through a couple examples. The first thing we're going to want to do is determine the rate of change, right? If that rate of change is constant, I have a linear equation, I can find the linear equation. If that rate of change is not constant, I can examine the ratio of the outputs and determine if something is an exponential function. So let's find my rate of change, which is my change in y over my change in x. I have 2 minus 5 over 0 minus a negative 1. That becomes negative 3 over 1, which is negative 3. Let's pick another set of 2 points. Looking for my change in y over my change in x. That gives me negative 1 minus 2 over 1 minus 0. So negative 3 over 1, which equals negative 3. And I could keep checking for each set of points, but I can see that this rate of change is constant, right? My y value goes down by negative 3 every time. So the equation for this function would be f of x equals negative 3 times x, right? This is a linear function. with negative slope. And I can put it in y equals mx plus b form. Remember that b is our y-intercept, which is this point right here when x is 0, y is 2. So the equation for this line would be f of x equals negative 3x plus 2. Let's take a look at another example. I have when x is negative 1, y is 32. When x is 0, y is 16. When x is 1, y is 8, and so on. So let's first determine our rate of change. So I'm going to look at these 2 points right here. Change in y over change in x. So I've got 16 minus 32 over 0 minus a negative 1. That gives me a negative 16. Let's pick another set of 2 points. If I have my change in y over my change in x, that's 8 minus 16 over 1 minus 0, which is negative 8. Okay, so this is not linear. I think it can then go ahead and compare the ratio of consecutive outputs. So let's take a look. Let's switch back to orange. If I have f of 0, which is 16, over f of negative 1, which is 32, I get 1/2. If I have f of 1 over f of 0, that's 8 over 16, which is 1/2. If I have f of 2 over f of 1, that's 4 over 8, which is 1/2. So this is going to be an exponential function, right? It's going to be a function where 1/2 is its base. However, we have a tiny problem. Well, not the tiniest problem. Let's take a look. Let's remember that when I have f of x of 1/2 to the x, right? If I have x is negative 1, that's when I get f of negative 1 equals 2. Well, here's the thing. I have when f of 3 is, when I plug in 3 for my x value, I get 2. So I have to notice that this is shifted 4, right? My x is shifted 4, right? Typically, if I had 1/2 to the negative 5th, that would be 32. But now I have 1/2 to the negative 1 is 32. So my x has been shifted 4. So I'm going to have f of x equals x minus 4 is my new function. And let's go ahead and verify that that's okay. Let's check it when x is 1. So if I have f of 1, that gives me 1/2 to the 1 minus 4, which is 1/2 to the negative 3, which would give me a positive 8. Okay, so we found the equation correctly. Let's look at one last example. First thing I'm going to want to do is I'm going to want to identify whether or not it's a linear function. So I'm going to look at for the rate of change. 4 minus 2 over 0 minus a negative 1. That gives me 2. Again, if I take 7 minus 4 over 1 minus 0, that gives me a rate of change of 3. So this is not linear. Let's go ahead and check if it's an exponential function. So if I take the ratio of f of 0 to f of negative 1, 4 over 2, I get 2. Then I want to take the ratio of f of 1 over f of 0, which is 7 over 4, which is 7/4, which is not 2. So this is not exponential.